That's the extent of my Spanish. So, me llamo Jessica. I am a senior cloud advocate with Microsoft, and I'm super excited to be here with you today, particularly because this is my first time in Madrid, so yay. I remember being in high school, and I saw the movie Love and Basketball, and I was a huge basketball fan, hence my Jordans, still am. And the female basketball player got to go travel and play abroad in Spain. And I remember seeing that saying, I want to go to Spain one day, so thank you. And the second reason how come I'm excited to be here is because we're going to talk about a subject that I'm immensely passionate about. We're going to talk about DevOps, we're going to talk about Waffles, you'll see why. We're going to talk about containers, though it's not in the slide, and we're going to talk about superheroes, because what could be more fun? We'll talk about how all those things tie together. So first off, before we begin, I always like to go through a brief disclaimer. This helps level set the audience so you know what you could expect from me and what we're going to talk about. Also, what you can expect to take away. This session was not designed to make anyone an expert. Sadly, in 60 minutes, there's only so much I can do, and I can't brain dump. It's not the Matrix. We can't plug a cord in the back of our heads. But the session was designed to get you thinking. It was designed to get you excited. It was really designed to kind of inspire you and show you what's possible. And then finally, it was also designed to offer resources at the very end where you can go and learn more. In fact, every single thing I'm going to show you is already online on GitHub, and you could fork my repo and recreate literally everything today. Let's make sure that we keep going. Slide is always a little fun. There we go. So I think it's no secret to say that life runs on code, right? It's a pretty broad statement, especially for everyone in the room, because we're all engineers. By a show of hands, how many people feel comfortable saying that they're a developer, software engineer? Okay. How many people feel comfortable saying you're more operations, or the artist formerly known as IT pro? And how many people wear whatever hat their boss tells them to wear? All of our hands should go up, or we need to have conversations with your boss. So regardless of whether you're a software developer or engineer in that sense, or you're an operations person or engineer in that sense, everyone in the room is an engineer. So for all of us, not only does our life run on code, but so do our jobs, so do our careers. And therefore, so does our planning and how we're going to scale and how we're going to deliver value. And we'll talk about why value is important. So I love this particular slide because it kind of points out just how much of our life revolves around code. For example, take the luxury car in the bottom right-hand corner. We can't actually put what the name of that car is for legal reasons, but let's just say that it rhymes with Schmeshla. Schmeshla vehicles use 120 million lines of code to run, which is quite surprising because a space shuttle only uses 400,000. And when I say only, that's still quite a lot of code to manage. And now think about when you're driving to work, or you're driving your kids to school, or you drove to this event, or you drive to the mall, or a sports arena. The urban traffic control system that you use throughout that drive uses 5 million lines of code. And now we're starting to see such an advance in code and open source technology that we're also seeing code take place in an open source capacity in the healthcare industry. In fact, if any one of you have ever heard one of my friends and colleagues at Microsoft speak, his name is Scott Hanselman, he's talked about diabetes and living with an artificial pancreas. He calls it body hacking. So for him, that's Scott right there in the bottom left-hand corner, his life, literally and figuratively, in every sense of the word, runs on 160,000 lines of code. He has it hooked up to his stomach. It's actually quite a fascinating talk if you ever get the chance to listen. So there's so many different aspects of our life that runs on code, and from an engineering perspective, that's a lot of responsibility, and we'll talk about how we can handle that. But aside from just those key life-depending situations, there's also a lot of things that we consume on a daily basis that revolve around code, right? Aside from Schmeshlas, we also have other intelligent vehicles. We have smart homes, Apple TVs, Nintendo Switches, Xboxes, smart lighting, smart lawn watering, irrigation systems. I don't know if that translates correctly. But we also have smart devices with smart headphones and digital factories and automation when it comes to even from Amazon and Amazon's factories. Smart cities, which is like smart stadiums. and even digital retail. So when you walk into a mall, security systems, point of sale systems, all of that that we consume on a daily basis revolves on code. And so we're going to talk about how we deal with that. We're also going to talk, as the slide would suggest, or the title of the talk, we're going to talk about Waffles, and how Waffles is becoming more and more popular in today's industry. And not to mention, personally, I think everyone loves waffles. So some goals for this session from what you can expect to actually learn, aside from what the session was designed for. We're going to learn how we can add Docker and Kubernetes support completely from scratch. Now, just by a show of hands, this is always fun for me as a speaker because I never know what the audience experience is. How many people already have experience with Kubernetes? How many people have experience with running Kubernetes in production? Awesome. Sometimes people are like, oh, I've used Kubernetes, and then production, they're like, not so much. How many people have experience using Helm? Awesome, good. How many people enjoy writing Helm files or Helm charts completely from scratch? There's always some of you. I don't understand that. How many of you have ever heard of something called draft? So draft is going to simplify your Helm experience, and you can tie that then into your DevOps process. So we'll talk about that. Then we're going to run through, after we build a Helm chart, create a Docker file, do all of that from scratch. And we're also going to talk about security and the security of both your Kubernetes cluster and of your Helm charts and your Docker images. We're going to tie all of that up with automation. And I picked 2 different automation tools, or CI/CD systems. We're going to use Azure DevOps, because I do work for Microsoft. But I also have done this demo with Travis CI, with CodeFresh, which is a Kubernetes-specific CI/CD tool. It's actually one of the first tools that was completely container native, so every step runs in a container. Therefore, it's a container-based pipeline. You can do the same thing with Jenkins, which I've done, and those files live in my repo as well, but I won't demo that today. You can do it with Octopus Deploy, and you can do it with GitHub Actions. Literally any CI/CD system. We're going to talk about what's involved when it comes to planning. And then we're going to deploy our application to Kubernetes on Azure. Now, I'm going to use a lot of third-party tools in this. And the entire point is to show you that when it comes to DevOps and when it comes to Kubernetes, when it comes to containers and Waffles, as we'll learn, it's not so much about, do I pick this tool, which tool do I pick, but it's more about how we use it and why we use it and what purpose we're selecting it for. And then we'll also end with some tips about running Kubernetes in production and how you can plan for that throughout your CI/CD. So now we're going to, of course, open up with the definition. What exactly is DevOps? If you were asked to define it. Microsoft's definition, and the team that I work on, which is led by Donovan Brown, and then I report to Abel Wang. We're members of a DevOps advocacy team and work closely with the DevOps org within Microsoft. We believe that DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on that slide is value. Because if you're not delivering value, really what are you doing and why are you doing it? And more importantly, how do you know if you're delivering value? How do you gauge that? Do you have telemetry, metrics, insights? As it turns out, when we start getting more invested in Kubernetes and container orchestration and abstraction, things start getting a lot more complicated. And it's a lot harder to see what's running where our deployments are succeeding, are failing, if we're delivering something of value to our end users. And we're going to talk about how we can plan for that and account for that. There we go. And so now, why do we care about containers when it comes to DevOps? Well, as it turns out, DevOps is a key component that really helps us communicate when it comes down to DevOps as a culture. How many of the developers in the room have ever had the conversation, you deliver your code, you zip it up, you SCP it, whatever you want to call it, and then your ops person is like, yeah, it doesn't work. Your response is, it works on my machine. It's a funny joke, but it's also true, right? And then the developer's like, give me a USB drive, give me a zip disk, give me the keys to your server, and I'll take it, I'll beat it with a hammer, and I'll make it work. But obviously, from an ops perspective, we can't do that. We can't do that for several reasons, security being a primary reason of it, but also, trust me, as a developer, you wouldn't want me running on your servers. As an ops person, I want, and this is where it gets fun, from a DevOps perspective, operations and devs were historically incentivized to work against each other. As an ops person, I want the lights to stay on, which means I want as little change as possible. You are not touching my server. But as a developer, I want to constantly iterate new changes. I want to be fast. I want to roll out new features. I want to deliver value, right? which means I want as many changes as possible as quickly as possible. So I want my dev system, my dev environment that I've put in a request for and I'm waiting now a week or 2 weeks or however long. But it gets really hard when we're trying to work against each other. So containers enables us to really focus on the purpose of DevOps, which is that continuous delivery of value. If both developers and operations are both focused and incentivized with the same concept, delivering value, we can work together. So now containers enables this write once, run anywhere application architecture. In fact, it actually sets up a foundation for microservice infrastructure. And from an operations perspective, now it gives me greater portability. It gives me greater standardization. Now I don't have to worry about dev, QA, test, canary, prod being potentially different environments, running potentially different versions of dependencies or whatever's necessary for my application that I wouldn't even know because I'm not a developer. It gives me abstraction, higher compute density, scale, right? Even if I am not using Kubernetes, I can scale out through a web app service or through a cloud-based service. If I am using Kubernetes, I could do cluster-based auto-scaling. I can do pod scaling. I could do event-driven scaling with something like Kata. I have so many more options when it comes to containers. And now from a DevOps perspective, every engineer in the room can now be incentivized with the same goal. Now, just in case, since we mentioned that this is a talk about superheroes, for anyone in the room who happened to be a part of Thanos' snap and disappeared over the last 5 years, we're going to recap real quick what Kubernetes is. It's an open source container orchestrator. It was designed to automate deployment, scaling, and management of applications. Essentially, and to put it very simply, it was designed to simplify automation. In fact, if you look at a lot of the things that Kubernetes does, self-healing, rollback, load balancing, any of those features, even secret management, all of that, I believe, became popular because it's built on standard DevOps practices. So how can we simplify automation? Let's build it on something solid. Let's build it on something that can enable repeatable delivery of value. So now I want to go into a demo, and we're going to use Draft and Helm. Now, obviously, a good majority of you raised your hands for you know what Helm is. For those of you who didn't, Helm is the de facto Kubernetes package manager. It's powered by a template engine, which means rather than having multiple YAML files within Kubernetes, deployment YAML, config map YAML, service YAML, ingress YAML, all my different YAML files, especially something that's scattered across multiple microservices, now I just have templates that use variables. And I use one YAML file, called a values YAML file, to actually control all the knobs and dials. Everything gets put into that value file, and then the Helm chart, or the templates, the template manager, is going to go ahead and parse that. Now, as we mentioned, and as the 3 people who raised their hand that said they enjoy writing Helm charts from scratch, most of us do not, we're going to talk about Draft. Draft was designed to make Helm simpler, and Helm was originally designed to make Kubernetes simpler, which is funny because Kubernetes was then designed to make other things simpler. Notice on how we're continuously moving on a simplicity path. How can we make this simpler but still deliver value? So Draft is going to help streamline Kubernetes development, and for any developer in the room that doesn't like or doesn't understand anything when it comes to Kubernetes or Ingress or all the complicated, more ops-driven or focused concepts, Draft enables you to get started with Kubernetes and Helm with 2 commands. That's it. And you can start completely from scratch. So I want to show you that demo now. So I'm going to switch over to Visual Studio Code here. And you're going to notice on the left-hand side, we'll zoom in, I do not have a Docker file. This is not smoke and mirrors. I'm not faking anything. I don't have a Docker file, and if I scroll up, I don't have a charts directory. I have a bunch of other scripts, and you can see I do have pipelines YAMLs and DevOps YAMLs, and we'll talk about that. But I don't have anything whatsoever that's Helm or Kubernetes or Docker related. Now, why is this important? This is important because I didn't write this code. I forked this repo from somebody else. And it's a Java application, uses Spring Boot, has Maven packages. When I originally designed this demo, I wanted to pick something that wasn't Hello World. So often we see somebody take a Python app and echo something from scratch, and look, I built it and it runs, great. But what happens if you're trying to take something that's real world, something that's already used, something that somebody else wrote, that all you know are what the resources that the application needs and the port that it listens on? how complicated would it be to get it into a Kubernetes cluster? And more importantly, how complicated would it be to get out into Azure? So this is, like I said, Java application using Maven. If we take a look at the POM file here real quick, and we'll zoom in, you'll notice I also have some distribution management set up. I'm using JFrog Artifactory for my Maven artifacts. JFrog Artifactory is a platform and a third-party service that will allow me to store virtually any type of artifact, not only Maven artifacts, but Docker images, Helm charts, everything. So I'm going to use that for all of my artifacts here. I'm also going to use the JFrog command line to handle anything that I would need to build. So there's a few things. Let me clear the screen here, and we'll zoom in. There's a few different ways that I could actually create a Docker file. I could use the built-in Visual Studio Code extension called Docker, where you just search in the marketplace, click on Docker, and this actually gives you some nice syntax highlighting. It allows you to work with your Docker file, but it doesn't do anything for Kubernetes. So instead, we're going to use Draft, which is a command line tool, and we're going to make sure, if we zoom in here, you're going to see on Docker preferences, Docker desktop. Here we go. I am running Kubernetes right now locally on my system. I just have Docker desktop. You can install it on Windows, you can install on Mac, and you check a box. We're not even going to touch the cloud. So I'm going to be working against that cluster. We'll close this. And I'm just going to make sure I'm working against it by switching to bad Wi-Fi. That's my secret tip, making sure that I'm doing everything locally. And now I'm going to do draft create. And just like that, it's going to detect the languages. So chances are my application probably isn't written in YAML. It detected some shell scripts, but it's probably not written in shell. And then it found JSON. It's not written in JSON. And then it found Java. Oh, that's a programming language. I'm probably writing it in Java. So now if we go over to the left-hand side here, you'll notice I have a Docker file. If we zoom in, we'll see that it's a multi-stage Docker file, right? Lines 1 through 4 is my first stage, which is going to build. It's going to run my Maven commands. It's going to package everything up and build it inside my container. And then I'll copy that over in my second stage, where I'll take, again, another image, and I'll expose the port. This is the wrong port, so I would change it to port 8080. We'll change this to port 8080. And then I would also change down here the command it's running. It's going to look for a file that has -- with dependencies. That's not the name of my application. So just like that, I could build this Docker image. But since I'm using JFrog, I actually want to use JFrog's Maven build so that it'll pull my artifacts from my JFrog artifact repository. And the benefit of using a private package feed or a private repository is now I control everything from a security perspective. So I'm already starting to plan ahead for any command I would run locally. I'm going to have to run that same thing in my CI/CD. Anything that I'm considering locally from security, I'm going to consider also as part of my pipeline. So let's go ahead and run JFrog RT. I'll show you the command. I'm just going to run Maven clean install. I'm going to add a few different variables, project version, and say that I want to publish my build info over to Artifactory. And I'm just going to hit enter. That's going to start running my Maven build, and it'll produce a jar file into my target directory locally. Now, while it's doing that, let's take a look at this Docker file again. First off, I don't want Maven to run because there's no reason to run it twice. I'm going to run JFrog as part of my pipeline. I'm not going to need to run this. And on top of that, I don't want to use JRE Slim because that's a Debian-based image, and because I also have security added into my entire process, I already know that this Debian-based image, A, is not allowed by my enterprise, and B, has over 110 different security flaws with it. So I'm going to make a few changes, and we'll walk through the changes we're going to make. First off, you'll notice here was the previous image that a lot of people, I've gone to customers, a lot of customers still use that image in production. Some people have updated where now they're using an Alpine-based image in production, and that's great, but you don't know what's running in that. You don't control it, you don't own it. So instead, I'm going to take an actual image that I own, which is an image that I patched and that I modified that is now in, again, JFrog and Docker. I add bash to it so I can run scripts and commands as part of my pipeline, and then I start doing things that make sense from a Java developer perspective. I start adding arguments and Java ops. And the only thing I do in my Docker file is copy my jar file over, expose the port, and run the application. My Docker file got a lot simpler, which means it got a lot smaller, and now it's going to be a lot easier, and it's going to have a faster startup time. So now that I've built my jar file, the next thing I have to do is take a look at my charts directory. We'll save our Docker file. In charts, like I said, I control everything with a values file. Let me close this terminal real quick. Here's my values file. I have replica count, image, pull policy. This is everything that draft gave me, right? I didn't have to write it. So if we go over to, let's say, one of our templates, like deployment template, and let's just zoom in and highlight anything with values, you'll notice value starts getting selected all throughout the screen. That's because anything in my template is going to be handled by the values file, so I can define anything there. So one of the things I know I want to do is I want to make sure that my build ID is in quotes, because otherwise, because I know my CI/CD system, it will fail. So we'll do that. When I'll also go back over to the values file, and we'll just make a few changes to run this locally. First off, I'm going to make a change to the port that the application listens on, because we know it's 8080. I'm going to make a change to the CPU usage that I need. Setting resource and requests and limits, by the way, is a best practice. You would also want to set health checks and readiness checks as well, but that's outside of the scope of today's demo. So right now, all I have is a very basic values file, right? It doesn't do anything with private images. It doesn't do anything with cloud. But now we're going to test it. So I'm going to clear the screen. I've only run one draft command right now, right? I've run draft create. Now let's go ahead and do draft up. Just like that, it's going to build. Whoop, as it did not build. Did I save? Let's go ahead. This is always fun. Live demos. Let's go ahead and do some debugging. Okay, so it got an error while building. It can't find the target file. Draft, by default, for some reason, adds a nice little thing to my Docker ignore file. Anyone want to guess what it is? It ignores my target file. So we'll go ahead and clear that, save, zoom back out, and rerun the command. Whoops. Reran draft up. And now it should be able to go through. It'll build my Docker image, and it'll release it to my local Kubernetes cluster. So we can see it build and release. By the way, when things fail like that, it's important to know what is happening in your process and how you can immediately troubleshoot that. So now that we've released that, I can actually see k get pods. K is an alias, by the way, for kube control or kube cuddle or kubectl, whatever you want to call it. K is just a universal way to make everyone happy. You can see right now it's 15 seconds old. I can do the same thing for k get service. You can see, again, my service is about 30 seconds old. I can even do Helm ls because it was released from a Helm chart. And you can see right now I just deployed it, 1532, it was deployed. So now I could port forward, right? For anyone in the room, you know Kubernetes, I could do kubectl, port forward, over to a deployment, a service, a pod. But for anyone who's new or any developers that those are complicated commands or your environment isn't set up for that, draft makes it even simpler with an extra bonus command. All I have to do now is do draft connect, and so we'll click right here. And as I didn't type the remaining letters, draft connect is going to go actually connect over through a proxy that'll be created completely for draft. I don't have to do anything. It's not anything that I'm telling it. It starts running the application, and it gives me a running log so I can see everything. When you use port forward, you don't get a running log history of what's running. So we can scroll up here, and we'll scroll over. Here's our local host, and here's our port. I'm just going to copy this. We'll zoom out, switch back over to our browser, and open a new tab. You can see right now it's loading from localhost. Here's my application. We'll go ahead and start chatting. Call this ChattyBot. Hello, DevOps Days Madrid, and the application is running from my system. In fact, I can flip back over to Visual Studio Code, make sure that I kill the running draft connection. We'll go back over to Chrome, refresh, and the application is no longer responding. So just like that, I could get started completely from scratch. Now, of course, I still need to get it out into Kubernetes and in the cloud. Now, whether I'm using Google, whether I'm using Amazon, whether I'm using Azure, IBM, Oracle, it doesn't matter. I'm still going to add I'm going to need to add a few things. For one, I'm going to need to add image pull secrets, and I also have provisioned secrets previously as part of my DevOps pipeline. So I'll go ahead and give it an image pull secret name. Of course, I could create a service account to do that as well. Then I'm going to go ahead and add in Ingress support. And then finally, I'm also going to add in some application insights. Application insights allows me to directly see the performance of my application and not just the performance of my pod or the cluster or anything else relating to my deployment. It's insights into the running performance of the application itself. Now, anything, of course, that exists in my values files needs to also exist in my deployment YAML. So we'll go back over here. We'll go over to our containers. And we're going to go too far down. We're going to go over to our containers, and we'll add in another check. There we go. So now we're going to say if values image pull secrets exists, add this in. If it doesn't exist, you don't have to add it. And I can do the same thing for resources, right? So we'll go over here. I'll paste in environment variables. Now the last thing I need to do is I need to account for Ingress, because I don't want to have load balancers running all over the place. I actually have an Nginx proxy set up on my cluster in Kubernetes. It also has certificate manager set up. It has Let's Encrypt TLS auto provisioning set up. But if you'll notice, under metadata, I don't have any support from the default draft file for any kind of annotations. And if we go back and take a look at our values file, you'll notice Ingress is expecting some sort of annotations. I have to tell it what the Ingress class is, what the cluster issuer is. TLS support, I need to make sure that I have enabled as true. So we're going to make a few changes here. And let's break down the changes we made. You'll notice if values ingress annotations exists, go ahead and add the annotations. Scroll down a little bit. If values ingress TLS exists, go ahead and add TLS. So now, just with those few changes, I can commit these changes and start a pipeline. Now, the one thing I'm going to change is we're going to go ahead and commit this Docker file. So I'll go ahead and say, I already had the chart and everything already committed. We're going to say live demo patch, and I'll show you why it's patch. So we'll commit, and we'll push. Now, I've already fired off a pipeline right before here, and I want to show you a few things. We'll talk about this in a few minutes, but I fired it off before I got here where I've already done a build, and I used that default image that Draft gave me, an image that I didn't know anything about, that was Debian-based, that I had no control over. I have my artifact build information fine, but the build actually failed, and I got an X-ray scan report. It failed because of the vulnerabilities. I could account for that in my pipeline. And we'll talk about that after the next few slides. And we'll take a look at that report too. So now let's go back over to our slideshow. All right, so now that we've learned how we can get started, play with containers, play with Docker files, play with Helm charts and Kubernetes with really just, I call it 2.5 commands because of the connect commands. Let's make sure that no one was lost in that. And again, in case anyone was snapped by Thanos' fingers, let's recap on what a container is. Because I still go into customer meetings to this day with people who have been using Kubernetes and containers and everything for the past few years. And when they talk about a container, their response still is, well, it's kind of like a virtual machine. It's nothing like a virtual machine, right? It's, number one, it's not a virtual machine at all, nothing like it. It's not even a real thing. When you think about it, it doesn't exist. It's not anything that's tangible. It's an application delivery mechanism with process isolation. But again, because this audience is quite experienced, as you know, it does not have full process isolation. Unless you also have Hyper-V isolation, you have additional security policies put in place. What happens if something jumps out of the container and attacks the host? These are all things that we have to consider, even from not only a DevOps perspective, but a DevOps with security, or DevSecOps perspective. And for anyone who's unaware, containers were actually based on several key Linux kernel features. Things like namespaces and C groups, what a process can see versus what a process can use. That's one of the reasons they'll come when we break down our Helm chart, and we could actually reference, I want to give this process 256 megs of CPU, 512 megs of RAM, whatever that is. It's because I'm allocating what the process itself, the process isolation, the delivery mechanism can use. Now here's where Waffles comes in. A container is a delivery mechanism. It's kind of like a waffle. Now, how many people enjoy eating waffles plain, without butter, without syrup, without anything? There's always one. Just feels like I'd be thirsty all the time. It'd be like, I'm just eating dry bread. For me, I want all the fun stuff, right? I want syrup, I want strawberries, blueberries. This is also why I have to work out all the time, because I love this stuff. But that waffle becomes a delivery system for happiness to my stomach. Or in another sense, it becomes a delivery system of value, something that is worth it to me. So when you think about a container, it's just a delivery system, and it has to deliver value to who's ever going to consume it. So now I'm starting Waffle Ops. Containers are like waffles. Now, how does virtualization differ from containers? This is why when I talk to customers and they say, well, it's kind of like a virtual machine. It's nothing like a virtual machine. There's two types of virtual machines, right? You either have a hypervisor sitting directly on top of your host OS, or you have a hypervisor sitting directly on top of your bare metal. But in either scenario, you're still going to have an independent operating system with an independent set of binaries, dependencies, package files, updates, everything that you have to control that you're responsible for, and then also an independent set of applications or necessary applications that are running, which means virtual machine A differs from virtual machine B, and virtual machine B differs from virtual machine C. Now, containers changes that, because now you have the host operating system that still sits directly on top of your infrastructure, but now you have the Docker engine that sits in between that. That's your container runtime. And that's what allows for your containers or your encapsulated runtime environments to run completely independently. So now my application dependencies are coupled right alongside my application, and that container becomes completely portable. Now, we've already kind of recapped on some of the benefits of using containers, right? It solves the, it works on my machine debate. But now it also gives me something that's completely repeatable. I know that because I ran that image locally on my system, it worked in Kubernetes. I could run it in Docker outside of Kubernetes. I could run it on your system. I could run it in Amazon's cloud, Google's cloud, my cloud. I could run it absolutely anywhere, even on Raspberry Pi and IoT devices, and it's going to work the same way. I never know if this next joke is going to hit, depending on the country I'm in, but I feel like containers is kind of like Oprah. You get a working system, you get a working system, you get a working system. Everything works, and that's one of the nice, reliable features. I also have a fast startup time, especially from a recovery perspective. Previously, if you had infrastructure as code, or you had an unattend file, or you have a DevOps pipeline that's standing up your infrastructure in whatever sense, even from a virtual machine, it's going to take a long time to start up if something completely died from scratch. Now, having a container, I put it and it's up and running in a matter of seconds. As we talked about, I package my application, my dependencies directly with the application, and then containers run everywhere. Now, let's go ahead and remind ourselves of the different types of Kubernetes architecture. First off, there's self-hosted, so this is something if you're managing it, I'm so sorry because that's a lot of work. You're responsible for all of these things. You're responsible for the API server, the database, the scheduler, the controller manager, the cloud controller. You're responsible for that, and you're responsible for the entire agent pool, all of your worker nodes, including the pods that run on it. And you're responsible for communicating with the Kubernetes API. As the user, you would submit your application or your workload definition that's either straight up YAML, Helm file, Helm Charts, whatever you want to call it. You're responsible for this entire chain of supply. But if you're using some kind of a managed service, whether it's Azure, which is going to be my graphic, or Google, or Amazon, now that cloud provider is going to take care of a lot of the complication. So all you have to worry about is making sure that your workload definitions work, and your agent pool is up and running, healthy, and your pods are running. We take a big part of what could go wrong and manage it for you, right? And then we back it by an SLA as well, so it's still self-healing. So there's a lot of benefits when it comes down to using a hosted platform. In fact, I have a funny video that if we have time, I'd show at the end, but it's real-life footage of what happens when you try to run Kubernetes yourself, especially in production. It's pretty great. Hopefully we'll try to have enough time. So now we're going to go through another demo, which I just gave the spoiler from that picture, and we're going to add some DevOps to the mix, right? You already know that I have a pipeline, and we'll talk about how I built that. But we can see, let's go ahead and zoom in, the pipeline had already ran. It's been running after I checked in my Docker file, and now we don't have any kind of vulnerabilities. But let's take a look at what we did have, and then we'll take a look at the pipeline. So I'm going to first click on the scan report, because this is going to be the first thing that I care about how healthy my application is and why it didn't work. So we'll log in, make sure I'm zoomed in here. You can see my build number was 1881. I had 20 violations and 110 security flaws. And because I made sure that I put this into the pipeline, I have that insight. I could run this scan still from command line, but I want something that's going to automate it for me. Now, if I want to see, if I scroll over, I could see the component. Most of these components are starting from Debian. Since my jar file itself doesn't have anything that's Debian specific, chances are it has to do with my Docker image. So we can actually confirm that by going to locations. I can click on the resource itself, and over on the right, I can view more info. And right here, it says, oh, well, it's related to this build. But this build actually responds to Artifactory, where I mentioned I have all my artifacts. That includes my jar file, my dependencies. I even store things you can see with the number of artifacts being 1 right here. And then I have 2 right here. Those are my jar files. And then I have 9. That's my manifest. So let's go ahead, and it looks like this became super small. There we go, that's why. So here's my manifest file, and here's all my different SHA, thumbprints, everything. Now, if I go over to, again, this little tree where I want to see the Docker image itself, the first link I clicked on for my X-ray was the entire build, and the build failed because something was insecure. But now I want to trace down what was insecure. So I found, okay, here's my Docker image. I can go over to X-ray, and we can remember that the build number was 1181. I can see that right here. I can click on more details in X-ray. And this is one of my only complaints, is when it drops me into X-ray, I'm not dropped into any particular build. So to fix that, we'll go over and just add 1181. And just like that, I'm dropped into, okay, here's my actual image. In fact, if we zoom out just so you can see, and I see exactly what was highlighted, 1181. And here's all the violations. So I know that it was related to that Docker image. That's another reason why we want to consider every single part of our pipeline, every single part of our process. So we patched that, obviously. We made an image from our Docker file, something that we own. And just to remind you, we did this particular image. The copy of that Docker file is in my repo. But now that we've patched it, if we go back and we zoom out, you can take a look that now we have a successful report. So now I can drill down into this information, and I'll actually be able to see that I went from 20 violations and 110 security flaws to only 2 security issues, one of them being medium. And I can drill down in to see, okay, how secure is that medium? Is there something I could do to patch? Because as of right now, there is no current fix for that. But once the fix becomes available, I can put that back through the pipeline. Now, since this is a DevOps talk, I know everyone's wondering how that pipeline works. Well, let's go ahead and refresh this page here. And you'll see I have my live demo patch that I just did that was completely successful, and then the revert demo patch. Let's go ahead and take a look at the live so we can see all the stages. You can see my build stage. Now, let's talk about what it's doing. First off, it's running through and it's doing JFrog install. It's making sure that my CLI is installed. This is the same thing I would do locally. And then it's running my JFrog Maven build. This is the same thing I did locally before we built our Docker image and pushed it into Kubernetes. Then from the cloud, obviously, I'm going to build and push that somewhere. I'm going to push it into some sort of private, highly available container registry. I just happen to choose Artifactory. You can do it with Google, you can do it with Quay, you can do it with Amazon, Azure, it doesn't matter, but you want to put it somewhere and have some level of security. Afterwards, this is just best practice I recommend to make sure that you have Helm and Kubernetes set up on your build server, especially with the specific version. And then I go through and I do Helm lint and Helm package. It's great that I wrote my file and everything looks like it worked locally, but I want to make sure I have that guarantee, that test, as part of my pipeline. And then I do JFrog publish. That's another JFrog command line that's actually just going to publish a whole bunch of information over into my Artifactory. That's how I was able to get information about the Docker image. I could even see things like environment variables. I could see absolutely everything related to the build. And then I have 2 things that are doing Slack triggers. I'm doing a build trigger where I publish information about the build, and I'm doing an X-ray trigger where I publish information about the security scan. Now, fun fact about when I wrote those particular triggers, I originally had grand expectations. I'm like, oh, I'm going to do something really cool. I'm going to create an Azure function. I'm going to have it call a webhook. I'm going to have it fire off, and it's going to be awesome. Why? Why would I do that, right? That's overly complicated. I want to keep things as simple as possible and as tightly bundled. All I had to do was click one link, get sent over to my security scan. I could drill down into things from there. I could even see the build history. I don't have to jump all over the place. The more complicated I make it, if it's unnecessary, the more I have to manage. So both of those steps are actually just curl commands, and they're just posting a message. And then from there, that job is done. Once that build completes, then we can move on into our deployment stages, where I could deploy over to dev. I could, again, make sure Helm's installed and run my deploy step, which is really just running an Helm upgrade command. That's it. Now, I would do the same thing for promotion. Now, of course, best practice would be I also have gates in, deployment approvals, and all those things, but I actually also have a second system. And you can see that right here. I have CodeFresh Chatty Bot. CodeFresh, like I said, is a DevOps-specific tool for Kubernetes. So we can drill down into, I can see that I have a promote to QA. I'll go ahead and hit approve, and we'll go take a look at CodeFresh. Now, the reason why I try to use multiple tools, for one, CodeFresh is going to give us a visualization of what I have running on my Kubernetes cluster, But I also want to show you, this is the answer to a question that I get all the time. What should I use? Azure DevOps, Jenkins, GitHub Actions? The answer is, it depends. And I would argue it doesn't matter, because it's not the most important question you should be asking yourself. You should be asking yourself what's going to deliver value. Because as you're going to notice when I zoom in here, the steps that I went through in Azure DevOps are the exact same steps that I went through in CodeFresh. I used JFrog to build a jar. I used Docker build. I pushed it to Artifactory. I ran Helm lint. I packaged up my Helm chart. I ran a security scan. In fact, even down to the security scans, all the commands I was running, they're the exact same commands. In CodeFresh, they're running in containers. In Azure DevOps, they're running on a build server. There are a little bit different things that you have to consider when dealing with container-based pipelines, but the steps are the same, because I have what's going to deliver value is I want to deliver something secure, reliable, and what works. And then I can add in my checks of, yes, I want to go ahead and promote to QA, and I can even give me some notes where is my application listening? So you can see, here's my application right here. We'll go ahead and grab that, and we'll see that this was fully deployed. So we'll go ahead and hit enter. Oops, it might still be finishing rolling out. If we want to double check this, let's go ahead and switch to JDK8s, and I can do get pods. And you can see here all my pods, it looks like it spun up 49 seconds ago. We can see if this has fully refreshed. There we go. So now it's back up and running, and we'll go ahead and type in our username, and it's going to be the same application that we played with locally, right? I can do the same thing, by the way. Notice I have replicas running in prod. If I do get pods -n JFrog prod, that was my Azure DevOps. I also have more pods running there. And if command line is a little hard, and like I said, locality matters, if we go back over to CodeFresh, I also have things like DevOps Insights. Now this, again, is specific to Kubernetes. If you're doing things still with other architecture and web apps, this might not be the right platform. But from a Kubernetes perspective, it gives me a lot of insights. It shows me what I have running where. I can see my certificate manager. I can see I have 2 services up and running and what image it's working with. I can see the same thing for my CF Chatty bot, which I just deployed. I can see even my Ingress that I'm using, my Ingress controller, and I have 2 replicas of that, the image I'm pulling and the endpoint that I'm routing to. I see the same thing for JFrog and JFrog prod. So now I have more traceability into what's running, where is it running, which namespace. In fact, I could even drill down into my Helm releases, and I can see all of my Helm charts that are released, my Chatty bot dev environments, my CodeFresh deployment, my Azure DevOps deployment, certificate manager again, Nginx, and I even have RabbitMQ, which is a messaging broker service. And Kata's installed on the cluster, so I could even communicate with Kata and do event-driven scaling. I have and here's Kata right down here. So I have all of this set up that now I can visualize. And even more so, one place that's just outside of this tool, but I can go into the Azure portal, and I even have monitoring set up on my containers because we added in not only application insights, but I have health monitoring that was pre-configured on my Kubernetes cluster. I can see the CPU node utilization when I get spikes. I can see the health of my applications, the health of my nodes. I can see right now I have something that is not in a ready state, so I can go and respond to that. I have all this information that now I can visualize. Now I can use that to help me decide in sprints and in the future. So let's go back and we'll kind of wrap up just a little bit. I want to recap. So what happened? I had code that lived on GitHub. We started from scratch. We added a Docker file. We added a Helm chart. We tested everything locally, which I still argue is a best practice. I talked to some developers that they say, well, I don't know anything about Kubernetes, so I'm going to check it in and let the pipeline tell me if it's broken. Test your stuff locally. We're trying to make it easier. We're trying to simplify the complicated. So we used Azure DevOps and CodeFresh as our Kubernetes pipeline. We used Docker to build our application. We packaged it up with Helm, and we deployed it to Kubernetes on Azure. Our Kubernetes repository in this instance was JFrog Artifactory and X-Ray. I've done this before with Azure Container Registry, with Google Container Registry. I've done it before with even Aqua. You can do Trivy. You can do Twistlock as another security tool. What I do recommend, though, is make sure that you have security planned in as part of your process. Because what I would hate is something gets deployed out to production, and you have missed the security step, and then now you have a vulnerability that's live, especially on a crucial application. Now, this demo was cool, and we've talked about a lot of different tools. I've name-dropped a lot of these tools throughout it. And again, one of the most common questions I get asked is, which product do I use? If we go back to the definition of DevOps, DevOps is the union of people, process, and products. Products is last. First, it starts with people, making sure everyone's on the same page, we're all communicating with the same ideas and the same end goal of delivering value. And then we have to talk about our process. What is it going to take to deliver this application? What works for me is going to be different than what works for you. And what works for you is going to be different than what works for your neighbor. So we really have to consider not which product do I select, but which product is going to enable me to consistently, repeatedly, and easily deliver value. These are some of my favorite questions that you can ask yourself. First off, I like to stand by the acronym KISS. And in the States, that could either mean a band or calling your neighbor something very not so nice. But I like to say that it means keep it super simple as you possibly can. While the demo in some aspects, because I had 2 different pipelines, might have looked complicated, it really wasn't. All I was doing was setting up a YAML file that was going to run tasks repeatedly. And they're the same tasks that somebody would manually type in. And then I made sure that people on my DevOps team were notified via a Slack channel. And they had deep links back over to everything they needed to know, right? And we kept that as simple as possible so there's very little chance for things to break or get out into the weeds. I like to tell people, again, superhero talk, so another superhero quote, the steps you take don't have to be big. They just have to lead you in the right direction. Gemma Simmons, Agents of S.H.I.E.L.D., Marvel. But it's so true, right? So many people think, okay, I'm getting started with Kubernetes, or I've broken out this monolithic application. I have 11 different microservices. I'm so excited. I'm gonna go all out. Do you have to? Are you gonna go in the right direction if you do that, and if you invest all in to diversify your abstraction layers? Or what if you just start small? You start with one thing and you move on to the next. One of my other favorite quotes is, the most important step you take is the next one. So you just keep moving forward. Take small steps and just make sure you're leading in the right direction. You can ask yourself questions like, what are my main objectives? What am I promising my end users? What's going to enable me to deliver value? How do I know if I'm delivering those objectives? How do I know if I'm meeting that? What are my indicators? These are questions you'll see in SRE talks. But SRE is just as important when you're dealing with DevOps. One of the best ways you can ask yourself, or one of the best ways you can plan for what your pipeline is going to look like, and it's the same way I wrote this pipeline, is what do I want it to do? Where do I want to start? With any application, I'm going to start with compiling, right? I have to compile my code. I have to build. I don't care what language you write in. I'm going to have to push that somewhere where I can host it, even if it's not even a container, right? I have to put that artifact somewhere that I can retrieve it. And then I want to scan. That might be my unit tests, my code tests, my code coverage, my, obviously, security scans as well. Once that succeeds, then I can move on and move it through my pipeline. I can deploy to dev, and I'm going to want to run more security scans there, make sure that I actually have testing and failure planned as part of my pipeline. And then I want to run more, like I said, testing, but I want to run gates. I want to automate as much as I possibly can before I move on to the next stage. And then I promote it to the various QA, canary, prod. Now, for whatever you have on the left-hand side here, you're just going to plug and play things that make sense. Private package feeds, so you control the packages that are running in production. Private repositories, so you control the images that are running in production. Your security scans, maybe that's X-Ray, maybe that's Aqua, maybe that's Trivim, Twistlock. Pick something that's going to offer you value. And then you start piping in your CI/CD. And one thing I didn't mention in here is GitHub Actions, and I get asked about that all the time now, so don't worry, I got you covered. We're going to get to that in a second. But then you start running through, again, you just start rinsing and repeating throughout your pipeline. No matter what you pick, the foundation is going to be the same. It's going to be the same commands that you run locally. You're just going to want to make sure that you're picking the process and then structuring your CI/CD the right way. And, of course, as I mentioned, even with my own debacle with Azure Functions versus curl versus whatever I wanted to pick, ask yourself, does this add value or does this add unnecessary complexity? If it's going to add unnecessary complexity and it's going to get out into the weeds and it's going to look super cool but be very challenging to manage, it's probably not something that's going to consistently deliver value. And if so, does the complication outweigh the value? Remember, at the end of the day, the entire process is just a waffle. You're just trying to deliver something that somebody's going to use, right? And you're just trying to make sure that they are consuming it. The more metrics, the more insights, the more traceability you have, the more you're going to know if people eating your waffles are happy. Maybe your bread is too hard. Maybe you didn't put enough water or egg or whatever it is. You want to make sure that it's just a waffle. Don't overcomplicate it. So now the last thing I want to talk about is the demo worked, right? It was cool. But let me ask you something. Let's say that we're running in production and we're running in a data center. Say that it wasn't on Azure or it could be on Azure. And something happened, right? And I'm not talking the application failed because we have a pipeline. We could redeploy our application. What if the data center were hit by lightning? What if everything failed? My cluster's gone. And for whatever reason, I didn't have failover into another cluster, into another zone. Everything is gone. What about standing up my infrastructure? There was a lot of components that went into that. I actually had a Kubernetes cluster that was production ready. It even has things like Calico running on it. Who's heard of Calico before? Okay, a handful of people. So Calico is an open source tool that I can use to actually apply network policies. By default, everything in your Kubernetes cluster is a flat network. One service can easily and immediately communicate with another service, which means now I have production level applications running on my application, and I can have a malicious Alpine container start sending requests, and that Alpine container can communicate with any one of my production services. So I want to lock it down, and Calico allows me to. But in order to use Calico, I had to plan for that in my Kubernetes deployment. So I had to make sure I deployed it with a certain network policy, with saying that I wanted Calico, saying that I even wanted things like availability zones for failover. All of this was very intentionally designed, but neither one of the pipelines I showed you could restand up that infrastructure. And if I had to do that manually or kick off a different pipeline, I would kind of be spending several hours or several days recreating that. So I wrote a pipeline using GitHub Actions that'll actually do everything you just saw, including the infrastructure. And it'll run through every time, so now I know without a shadow of a doubt my application will be deployed, because the first thing it's going to check is to make sure that the application is up and running, or the infrastructure is up and running. And if it's not, it'll create it. So GitHub Actions, by the way, if you're new, is actually built on top of Azure DevOps, but it's a way for me to automate my deployments without ever leaving GitHub, right? The GitHub Actions engine runs immediately just from GitHub. So it'll allow me to automate. It'll allow me to build, test, and deploy completely with confidence, again, without ever leaving my repo, which is perfect because it'll work with any cloud, any system, any platform. GitHub is home to 27 million developers, so now everyone can have DevOps. And on top of that, it's completely customizable with the commands you're already using. In fact, the commands I use to write the GitHub Actions pipeline, I copy and pasted from my CodeFresh YAML and my Azure DevOps YAML. And because they're just bash commands and I'm just triggering commands, that's it. That's all I have to do. In fact, I believe that GitHub Actions is easier to get started than even Azure DevOps, because you don't have to know about tasks, you don't have to know about structure, you just set a name and a run command. So I want to show you what that pipeline looks like. And this, by the way, is supposed to say full CI/CD. So let's go ahead and go back. We'll switch back over this time to our browser. And I have my application running here, or my application code here. JL Deen, Spring Boot application. Here's my GitHub workflows, which is where the YAML lives. Here's all of my code now. You can see the charts directory. You can see the Docker file, my Docker ignore. Like I said, I've done it with Jenkins, so Jenkins in there if you want to take a look at that. Azure Pipelines, CodeFresh. But all I have to do is click on Actions, and you're going to see that I have two pipelines. One of them was the failed pipeline. In fact, if we go back over to Slack real quick, you'll see I have another GitHub Slack channel where here were my two notifications from the successful one that we pushed live, and then here was the failed one from right before I got here. And I still have those same deep links. The pipeline itself hasn't changed. They're the same commands. It's just a different service. But if we go over and drill down into, let's say, the most recent one, you'll now see I have a fourth stage, which is the first one, deploy my infrastructure stage. And this is running through a few things. First off, I'm using Azure Command Line, which is cross-platform, open source, Mac, Linux, and Windows. And I'm going to log in to my Azure account. Now, I could do the same thing with Amazon. I would just log into my Amazon account, or Google, log into my Google account. And whatever your command line tool is, you use your command line to start structuring what's going to build your infrastructure. In this case, I created a resource group. You can see that right here. I created a virtual network. I created a virtual node subnet. And then I set up my backend infrastructure. Now, I could do this one of two ways. I could run an individual command, or I could have my infrastructure in an ARM template, something that also is immutable and something that's source controlled and version control. And that's the other benefit of keeping all of my infrastructure's code and my deployments and everything packaged right alongside my application and right alongside my branch. Now I still have that locality. I know what triggered it, what change happened, what broke and where. So I set up my backend infrastructure. I even installed virtual nodes on the cluster. That's if I wanted to do event-driven scaling with Kata. This is a cluster that's ready to start piping that through. I mentioned that I set up Calico. That was defined in my ARM template. I created a cert manager, Nginx. I configured that cert manager. I even created my namespaces and my secrets. And all of that gets run through every time before I ever get over into build and release. Because now I know that everything I'm going to build and release is guaranteed to be deployed because that infrastructure works. And the infrastructure will be updated in the event that something has changed or I have changed it. If I go over to build images, you'll notice that my build images stage is, again, just the same. I install CLI, I do a Maven build, I log into Docker, I build, push, Helm package. The steps don't change regardless of what platform you're using, but it is important to have good practices. In fact, one of the last things I did here was not only did I deploy my application to prod, but if we can zoom in just a little bit more, I labeled my pods for network policy. So now I could apply that policy appropriately. So now let's go ahead and actually see how that policy works. Because we talked about tips for running Kubernetes in production. One of the things is you're going to want to plan for all of this at conception, at build. You can't apply certain things like DNS changes, types of DNS you want to use, network policies after the fact. You have to do it at design, even if you're not planning on consuming those features now. But because I have a pipeline, it's very easy for me to say, I want to create this, and now I know that it's been created the right way. And on top of that, if I want to update it, I have a pipeline where I can make that change and recycle. So let's go back over to my terminal here, and I'm going to clear the screen. I'm working on my Kubernetes cluster. By the way, just to pre-answer anyone, if anyone wants to know how my dot files work or what they are, that's in the link you're going to get at the end. So the first thing I'm going to do is we're going to start actually an Alpine image. This is just going to run Alpine on my node, right? Let's claim that this is a malicious cluster. And then we're going to go and I want to get my services, and we're going to get services from JFrog Prod. These are my production ones. My ChattyBot service is the one I deployed with GitHub Actions, and so we'll copy that name over. And now I'm going to do a watch command. Watch wget, we'll paste this in, and let's go ahead and back up. We'll do .jfrog-prod because I have to give it the namespace. And you can see right now it connected, and it's saving my index file, right? It can't open the index because the file already exists, and it's going to keep flashing because I'm doing a watch command. Now I can scroll down here, and we're going to go ahead, and let's see if I can. There we go. So you can take a look at what this network policy is doing. I'm going to go ahead and hit enter. So first off, I'm applying the network policy. This Calico is already running on the cluster. And I could, by the way, do this as part of the pipeline. I'm just showing you. But I'm just making an application of I want to set a network policy. Here's the name of the network policy. Here's the ingress that I want to attach it to. And this right here is the label. That's the part that I defined as part of my pipeline. Add a label so that I can make sure that this policy can very easily be applied. And now you can see the network policy has been created. So if we zoom out real quick, and I'll go back over here, now this watch command can't connect anymore. In fact, I could kill it, and we'll go ahead and rerun it. It's just going to hang there. It can't get the file. I'll kill it even one more time, and we'll go ahead and do a rm-rf, and we'll move that index file. And now I'm going to scroll down here. We're going to go back up, and we're just going to delete that policy. Hit enter. The policy has now been deleted. So now that I've deleted the index file, just to prove this, and we do a watch command again, now the index is saved. That policy can choose to allow or deny traffic, and I've planned for that as part of my pipeline. So let's go back over to PowerPoint, and we'll just wrap up here. So now what happened? Now, regardless of whether we've used Azure DevOps, CodeFresh, or GitHub Actions, I've now planned for complete repeatability, even down to my infrastructure. And now I have a guarantee that the application, regardless of which environment it's running to, is guaranteed to work. I'm still going to go through and build my Docker image. I'm going to package up my Docker file, and I'm going to deploy it over to Azure. and then I still have JFrog Artifactory and X-Ray. That part of the process didn't change. I just added more reliability and predictability to the process by also planning for my infrastructure. Now, some best practices that you've heard me drop throughout the session. First off, you want to build as small of container images as you can. The first Docker file that Draft produced was a multi-stage Docker file. But the first stage, number one, did something that I was already going to do as part of the pipeline. And number two, also used very large images. Alpine images are traditionally, historically smaller than Debian. They're also safer. The smaller an image is, the faster the startup time, and the smaller the attack surface is. So now I start considering security. You'll notice throughout this entire talk, I've been consistently talking about security because that is so important when it comes down into DevOps and Kubernetes. In fact, there was a video that was popular that was running around recently that was talking about what happens after customers have been running Kubernetes in production for so long, and then they realize, oh, we completely forgot security. What are we going to do? Something we can plan for in advance at conception. We want to consider our application architecture. Use namespaces to isolate. Since a majority of you are familiar with Helm, the Kubernetes deployment that I had structured uses Helm 3. Who knows one of the biggest changes in Helm 3? Removal of tiller, right? I'll tell you that Helm 3 is the only time when we made that announcement at KubeCon EU in Barcelona last year, it's the only time you'll ever hear from an entire developer conference, hey, we removed a feature, and the entire audience cheers. Yes, you finally removed something. Normally, we don't like it when you remove things. But use namespaces. The reason why I mentioned Helm 3 is Helm 3, now with the removal of tiller, also gives additional security. Every deployment is per namespace. In fact, even your release history now gets created as a secret object. And that gives, we can talk about that afterwards, you can find me offline, that gives you greater security. Helm Charts. Helm Charts is considered a best practice. You could even use Helm files to manage multiple Helm chart releases. Role-based access control. Don't just give godlike privileges to every single thing touching your cluster, right? Production's running there. We talked loosely about even implementing health checks, implementing liveness probes, readiness probes, setting resource requests and limits. All of that is a best practice and needs to be considered at the very beginning. And then finally, we already talked about set requests and limits. Finally, be mindful of your services. You don't have to run everything in Kubernetes. You can rely on external services. In fact, I'm a big believer that I don't want to run a database in Kubernetes. I want it to be as easy as possible. So I'm going to use the managed database service and just connect to that external service. And then also, you don't want to rely on load balancers. One of the reasons I'm a huge fan of application routing or Nginx proxy is all different deployments, whether it was Azure DevOps, GitHub Actions, or CodeFresh, every single one of them all went through the same load balancer. I just routed it. We're just doing old school vhost comp files with that, only this time we're doing it through an Nginx proxy that's running on your cluster. Finally, my name is Jessica Deen. I am, like I said, a senior cloud advocate at Microsoft, and I'm here frankly because I love technology and community. One of my favorite things is getting to hang out with people all over the world, fellow engineers just like you. I focus heavily on anything Linux, open source, DevOps, and containers. I love all things Disney and CrossFit, so if you follow me online, you might see some of that. There's no relation to James Deen, which is, I never know if that's going to hit, but my last name is spelled with 2 E's. You can find me at JLDeen on Twitter, Instagram, and GitHub. And then finally, this is going to be the slide that everyone wants to take a picture of. To get all of the content, and I promise you there's quite a few links, you can go to aka.ms/JLDeen/waffleops. I told you I'm trying to coin that. And then thank you very much. Thank you so much for having me.